Welcome to this first of two videos over the next two nights that I'm going to be doing for our class to review some of the key information that you need to know for your test coming up. And I'm just going to be picking questions that I think are important for you to do, and you can follow along if you'd like. You can skip to other questions, or you can just follow this whole video. It's going to be approximately, I would say, 6 minutes or so, and that's how I'm going to time both videos. So let's start with the first question that I have. And let's start by saying, write the equation for the parabola given the information. And here's what we will start off with in question A. Question A is going to say the graph has a narrower opening than y equals 2x squared. And the key thing to remember for that is that the larger the number, the more narrow the parabola will be, because that will be a vertical stretch. So if we want a graph that is narrower than 2x squared, you could choose, say, 3x squared. You could choose 4x squared. You could choose, if you'd like to, say, 17x squared. As long as that number is greater than 2, we know that this is going to be more narrow than 2x squared. The next one, graph opens down, and is narrower than y equals 5x squared. Again, it opens down, so we need to have a negative at the beginning, and we need a number that is now greater than 5x squared to be narrower than 5x squared, so we could choose negative, let's say, 6x squared. You could choose negative 12x squared. Both of those options will be narrower than y equals 5x squared and opening down. Next, let's look at these two equations. First one, let's say y equals 2x minus 4 squared plus 5. And let's look at y equals 2 bracket x minus 5 squared plus 4. How are these two graphs the same, and how are they different? Well, let's see how they're the same first. These two equations, or these two graphs, are the same because they both have, or both are in, vertex form. They're the same also when we look at the vertical stretch. They both have a vertical stretch by a factor of 2. Now let's see how they are different. Let's call this parabola 1 and this parabola 2. If you look at vertex form for equation 1, we see that the vertex, and remember that is always given by the values of h and k, and the first one would be 4, 5. And it's a good idea just to remember that the h value inside the brackets, that will simply just change signs. So the negative 4 will change to our positive 4. And in the second one, we see that we have our vertex will be 5, 4. So what this tells us, in the first one, and by the way, these both open up as well, so this one has a minimum of y equals 5, because that's our k value, and the other one as a minimum of y equals 4. So that's how they can both be same and different if I was to ask you for that. Something else that's going to be key to know for the test, and this will be the last one I do for this review. Let's say that we have the equation y equals x squared minus 8x plus 15. I'm going to first say, let's write this in factored form. I notice in this case, because at the very beginning of my equation, that this is in fact a simple trinomial. So that means I'm looking for two numbers that will multiply to the last term and add to negative 8. And if we were to determine those two numbers, that would be negative 3 and negative 5. And because this is a simple trinomial, we can simply say that this will be x minus 3, x minus 5, and now this is in factored form. After we write this in factored form, we can determine the zeros, or my x-intercepts. And remember, my x-intercepts on a parabola are where it crosses the x-axis, and at the x-axis, y is equal to 0. So that tells me in this case my first factor is x minus 3. So x minus 3 can be equal to 0. So that x-intercept is 3. And or x minus 5, we set that equal to 0. So we get the x-intercept of 5. Notice basically all that's happened is the signs inside the brackets have changed to the opposites when we solve for the x-intercepts. From there, we can determine the axis of symmetry. And remember, the axis of symmetry is directly in the middle of a parabola. And to do that, the equation for the axis of symmetry, we simply take our x-intercepts, r and s, add them and divide by 2. So in this case, that will be 3, add 5, divide by 2, which is 8 over 2, and that is 4. So that's our axis of symmetry. And then we can determine the max or the min value. And how do we know if we have the max or the min value? Well, we go all the way back to our original equation and we see that we have a positive at the beginning. That means opens up. That means in this case we have a min value. And we take that original equation and we could substitute in the axis of symmetry. That will be 16 minus 32 as 15, and that gives us negative 1. And that tells us right there that our vertex will be 4, negative 1. Axis symmetry is the x value of your vertex. The max or the minimum is the y value of your vertex, which I have shown there. So our equation in vertex form will be simply y equals x minus 4 coming from the vertex squared minus 1 coming from the maximum or minimum value. And those are some things that you should really be good at when it comes to the test coming up soon.